Well, good afternoon, everyone. Thank you so much for joining us for EBMUD's Landscape Advisory Committee General Meeting with a special presentation on finding irrigation leaks. My name is Kristen Bowman, and I'm here with my colleague Lindsay Kinsler from EBMUD Water Conservation Division. So just a couple things before we get going about logistics. This is a meeting format, so you do have the ability to turn off and on your cameras and your mute, and we will have opportunities for live conversation, but for right now, as we get started, if you wouldn't mind keeping those off. We will be sending the video link to you with a number of the other resources that we talk about today as a follow-up email, so you can you'll anticipate that shortly. You can use the Q&A button for questions, and then you can use the chat for talking amongst yourselves. And also, we're going to be asking you to answer some questions, and you can use the chat for that. You might want to have a calculator and a pencil and pen or a piece of paper handy, because we are going to be doing some computations. We're going to start out with some more simpler computations and building up to things that are a little bit more complicated. There is a short survey at the end, and if you wouldn't mind filling that out. And just as a reminder, this is recorded, and by participating, you do agree to be on a recorded webinar. So just a few announcements. We have some upcoming events. June 1st, we are working with the City of Lafayette in doing a sheet mulching workshop. So if you have any questions about sheet mulching, this is an opportunity to get your hands dirty. And also work with Lori Codwell, who's really a sheet mulching guru. As a follow-up to today's meeting, we have an irrigation leak detection in-person workshop that will happen in Walnut Creek. So if you want to continue to refine your skills on this irrigation leak detection, please join us for that. If you are a designer, just as a reminder, the Pacific Horticultural Futurist Design Award applications are due July 26th. And if you happen to know any Spanish-speaking landscapers, CMPS is offering a landscaper certification program. It's a 9-session course, primarily online, and we'd love to get the word out on that. And I also noticed Rescape has a new heat qualification training that's in September, which is really taking a look at this heat island and climate change issues that we are addressing. So a while back, this group was curious about a lawn conversion payback calculator, and that was really looking at how long would it take to pay back that kind of investment of taking out a lawn and putting in a regenerative landscape. And that is just around the corner. We're just doing some beta testing, so I hope at our next meeting we will be showcasing that. Also new is the CalScape, if you haven't heard, the CalScape 2.0 web platform, which is really beautiful. And if you are a nursery, you can upload your inventory. And if you're a landscape professional, you can upload your profiles, and all that's for free. A couple new things with our landscape rebate program. All of our rebates are now issued as checks. It used to be a credit on your water bill, and now they're issued as checks at the end of the project, within 2 billing cycles. We also increased our, for commercial properties, the ceiling to 20,000 to help with this state law of converting, or actually the watering ban of non-functional turf, so to help out with a little bit of that. And to tie into today's presentation, we do have a flow sensor rebate, which is up to $250, and a new spring irrigation repair. So our spring irrigation repair is really just kind of a reminder to get out there. This is the time of year you want to be looking at your broken nozzles and valves and laterals, and we will reimburse you up to $1,000 per account. And the applications do need to be in by June 30th. So a little bit about our water supply. For those of you who are not familiar with EBMUD, we draw most of our water from the Colony River watershed, which starts up where about Kirkwood ski area is. And we're at 94% full right now, which is at 112% of average. And honestly, we're still benefiting from all those atmospheric rivers that went through our service area last year, filling up our storage. A lot of people think that we got a lot of rain this year. Wow, what a lot of rain. Well, we did get a pretty good rain, but it's 90% of average. So it was a little bit below average. And there is still a statewide drought emergency, which was put in place in 2022, and that's through June 2024. So it's coming to a close, and that prohibits irrigating commercial non-functional turf or decorative lawn with drinking water. And then to follow that, I think probably many of you have heard of the state law AB 1572, which will permanently prohibit watering non-functional turf or purely decorative lawn on commercial properties, starting with municipalities in 2027. If you haven't really heard much about that, I will be sending, as part of the follow-up email today, a really good video on that new law that's going to start up in 2027. We're all also here to help you answer questions about that. I want to take just a minute to look at our water usage in our service area, and is this graph below compares 2005 to 2007 to the last 2 years, 2023 and 24. And you can see, in 2005, we were way up in the summertime with our irrigation. And then it would, dip down if we had a good rainy season, then go up again during irrigation season. And we've saved so much water. Look at all where we're at now, way below our 2005 level. And I also want to just comment that it's pretty consistent the last 2 years, and we've had pretty good rain the last 2 years. But also, I think there's just what we're seeing is a water conservation culture where people are adopting these behaviors, whether it's improving their irrigation systems or adopting water conservation practices, both indoors and outdoors, regardless if there's a drought. So we call it here at EBMUD, our slogan for our water conservation culture is small changes creates a big splash. And just a little hint, you might want to know that for our trivia at the end. So an overview for our finding irrigation leaks. This is what we're going to be covering today, and it's going to come pretty quickly. So it's not one of those meetings that you can be multitasking, because we are going to really be building on the information that we're learning as we go. We're going to start out with some simple meter reading, both on standard and automatic infrastructure type meters, AMI, and then looking at AMI, which is online data, and interpreting that data to find leaks. We're going to look at irrigation zone designed versus flow rates and see if that can help us determine if their rate is leaks. And then also look at some leak detecting tools that you can use in the field, steps to detect leaks, some case studies, a summary, a trivia, and dopamine. So dopamine's on the house today. And the way that it works is that if you participate in our trivia, you get a little dopamine. And if you get the answer right, you get a big dopamine hit. So, and then we'll end with Q&A. We'll also have some time in here for asking questions. So we'll pause for that too. So with me today is Lindsay Kinsler, and many of you may know her, a prior landscape contractor with Brightview in Valley Crest prior to that. And we're so pleased to be working with Lindsay. She's a leak detector expert and has really employed this throughout our service area. With that, I'm going to pass it on to Lindsay.
Great. Thank you, Kristen, for that very kind and maybe a little over-exaggerated description or introduction. Hi, everybody. Appreciate your time this afternoon. So let's dive into meters. So most of us have probably worked with meters in some capacity, but it is basically a device that is telling you how much water you're using. Most meters are going to have 4 different types of registers, which we show a few examples here below. We've got a round dial, digital, solid state, and compound, which we'll discuss on our next slide. So how do we read all these different registers? So let's start with the lower left-hand corner. So this round dial, this one can be a little bit confusing and it's a little old school, but reading this one, you want to start right with the big numbers. So we're going to look at this lower left-hand corner, you see 100,000. That's where we want to start our reading. So if you look at the little dial there, it's between a 5 and a 6. So that first number is going to be a 5. We move clockwise around the dial to our 10,000s. Again, this one's between 5 and 6. So that's going to be a 5, right? Move up to that 1,000. That one is sitting between 8 and 9. So that is an 8. Go down to the hundreds. And that one, it's pretty close to that 0, but it's still sitting above that between the 0 and 9. So that one is going to be a 9. And then our last is over here, the 10th spot. That is between that 1 and 2. So that one is going to be a 1. And now if you look at the bottom of the dial there, you're going to see a little mini dial with no numbers on it. That is the 1 cubic foot dial. So right now that's sitting right at 0. All right. Next one, this one's a little bit easier to read. This is a digital read, and most of you have probably seen this one. This one, if you'll notice on the dial that we're reading, right, there's 4 numbers here in white, and that is what we call billing units. And this is what we bill our customers off of. The 2 numbers, which we still want to read and count in the black, are called odd feet. And we don't really use those for billing purposes, but we will want to know that for our total consumption. And so after that, so this dial so far we're reading 7, 6, 5, 4, 3, 2. That 0.135 comes from us reading the sweep hand, which is this long pointy thing on the dial here. And it is sitting at 0.1. And if you count those little ticks, right, it's between 4, it's kind of in between. So we read this as 0.135. And the next one, this one's super easy to read. This is an LCD. It's 8116.935. So who could tell me this last picture here on the right, what kind of register is that on that meter? Pop it in the chat or feel free to shout it out if you know what kind of register that is.
This one over here.
Yeah.
Compound.
Someone said compound.
That is a compound meter, but what kind of register is on that dial? What we got there? Yeah, that's right, digital. So we just talked about some compound, or someone chimed in with compound. Let's talk about compounded meters. Next slide there. So this is a compound meter. Compound meters are great for larger sites where you have you're using more water. They're really great too for sites that have fluctuations in the amount of water they're using at different times of the day. So this has 2 registers on it. It has a small dial and a large dial. When the system is using a lot of water or has really high flow, that large dial is going to pick it up. When there's just less usage, maybe a toilet flushing here and there, or maybe a small drip zone running, that small dial is going to pick up the usage. And then we're going to read these very similar to how we've read our other dials. So our small dial read would be 1375. And then if we look at our sweep hand, we get that 0.65. The large dial, that one reads a little bit different and could be a little bit confusing. Because it's a larger dial, we read this one, you'll see that those 2 zeros next to the digital register there are solid and they don't move. That is because we actually use the sweep hand here to get those additional digits on this large dial. So this one would read as 5-4. Then we look over at our sweep hand. It's a little bit past that 81, so it would be 81.5. Again, these are really great for when you have those large fluctuations on your sites. So now that we learned a little bit about reading the meters, let's take what we've learned about reading them and try to figure out our gallons per day flow rates from using meter readings. So what we want to do here is we're going to compare readings based on an amount of time in between them. So figure A is going to be our first reading. Figure B is going to be our second. So we want to write those numbers down. So figure A is 547,030. Figure B, which is our second reading, 548,010. Next thing we want to do is we want to subtract that first reading from our second. When we do that, we get 980 cubic feet, which is what these dials are registering in. We need to get to gallons. So we're going to use a conversion factor, which is 7.48. So that converts cubic feet to gallons. So we want to take that 980, multiply it by that 7.48 to get our total gallons, which in this case is 7,330. All right, now we want to know gallons per day. So we need to divide the time between our readings to get that number. So these readings were taken, it's 21 days in between our meter readings. So we're going to take that number, the 7,330 gallons that were used, divide it by our 21 days, and then that gets us to 349 gallons per day. So we've talked about gallon per day flow rate. Let's talk a little bit about gallons per minute flow rates, and let's use a meter to get this rate. So same principle, we want to get that start read, which on our dial here is 17.46 cubic feet. Then we want to take our second read, which is 18.05 cubic feet. Again, subtract to get our consumption. We're at 0.59, and then that's in cubic feet, so we want to convert that to gallons. So we're going to use that 7.48 conversion factor to get our gallons, which was 4.41. And now we need to know the time between them. So we ran this meter for about 32 seconds. So we're going to take those numbers, take that 4.41, divide it by 32 seconds. And that gives us a flow rate of 0.138 gallons per second. Now, we aren't measuring in seconds, we want to know minutes. So we would take this number, multiply it by 60 to get our gallons per minute, which brings us to 8.28 gallons per minute. And as a reminder, and we're going to use this formula here again, but this is the formula that we use to get these flow rates. And this was the math that we just did and just gave you an example here. So this is getting us a flow rate for our meter. So let's take it the next step. Or actually, let's talk about AMI before we take it to the next step. So we just learned how to physically read meters, and we learned how to calculate flow. Let's talk about meters that you don't have to actually physically go out and read. So AMI are smart meters. These are it's advanced metering infrastructure, and these are meters that allow us to communicate with us electronically. So we can get those reads without actually physically going out and opening up a box. If you look at this photo here to the right, this is an example of what an AMI setup would look like looks like on a meter. You'll see that black hockey puck looking disc. If you see that in your meter, you most likely have AMI. AMI also, it communicates with a software program that has computer algorithms that can help us look for leaks. It helps us identify problematic usages, and you can also set them up to provide you with alerts. And you can use the data you collect or get from these meters to forecast future water bills. If you want to know if you have AMI meter and you don't want to physically go out and look for the meter, you can also log into your My Water Report EBMUD portal, and you'll know if you have AMI or not. So what does AMI provide us? Like I said, we get all this data. We get hourly, daily, monthly, yearly data. It can help us identify what's irrigation use. If we're using a mixed meter, it can separate, okay, what is expected building usage? What's our irrigation usage? But one of the best things it can provide for us is if there's continuous usage or if there's unexpected or high usage. And like I mentioned earlier, it also gives us automated alerts and can help us forecast bills. But one of the biggest things and most important things is understanding that problematic usage. So this chart here is an AMI account for irrigation only. And something that, is glaring to me and probably is to quite a few of you that work in irrigation is if you notice around December of 2022, you see the usage drop, which is to be expected in the winter, but this is an irrigation only meter. So we would expect to not see any usage at all in the winter. Looking at these curves, you can see that you make some assumptions that it looks like the controller may have been turned off, but there might have been some ongoing mainline leak or stuck valves or some sort of issue that turning off the clock isn't going to resolve. And again, this being able to have access to this data and use this data can help us notice these issues and address them quickly. This is just an example of what 2-week usage period of a multi-use account. Again, it's giving us a nice breakdown here of what is assumed to be timed irrigation, what is normal use, and then that orange is what it is considering a possible leak. Why is AMI useful for finding big leaks? Well, AMI is great because it does help us understand what our expected usage, our actual usage is, so we can compare it to what we expected to be using. It also has really great algorithms, like I mentioned earlier, that can help us locate and identify leaks. It also will provide you with when that leak started, if a leak stopped and the flow rate of the leak, which is really valuable in helping you kind of identify what type of leak you might be dealing with. And again, if that leak continues to grow, which they sometimes do, it will also continue to alert you of the increased consumption. And all of this, having this data, having this information is just really valuable for us to work with our customers and help them understand what's going on with their usage, help them solve problems. So you're really doing yourself a favor and establishing really goodwill with your customers and your staff. So how do we find leaks, or how does AMI help us with this? This here is another example of an irrigation account. And what you can see here is starting around midnight on June 19th, this is what we would expect. We would expect that irrigation system to probably be on and running between 12 and 6 a.m., which the chart here shows us that it did. What the chart here also is showing us that irrigation was running from 7 a.m. all the way until it looks like another cycle or another program kicked in at 11 p.m. the next day. So here, this is a great example of where you could take this info and look at your irrigation schedules. And unless you were running like a drip zone or something during the day, you probably wouldn't have had this kind of usage. So it would let you know, that's letting you know that you got something going on, that there's usage, unexpected usage on this system. So what are some questions you want to ask? You want to ask, should there be 24-hour usage on a system? And there very well could be. I had a site, I had over 400 valves in one point of connection. And half of the site was turf. That irrigation was running 24/7. There was not a single minute in the summertime that system wasn't running. And that's okay, you know that information. So when you look at the AMI data for an account like that, you understand and you can manage the expectations of that customer. Are there days when something shouldn't have been running? Did you have an event that you put a pause on the controller? Is your summer and winter use the same, or is your winter usage lower, which it should be if you're using irrigation? And then does that irrigation usage actually match your irrigation budget? And then, something that you really want to know too is the history of your site, right? Were there repairs previously made? We've all sent a tech out in the field and had them fix something and the fix didn't hold. Maybe they didn't let that pipe loose that long enough or didn't install something properly. It's always good to go and double check those things and see if that is the cause of the issue.
So we're just taking a little break right now to see if there's any questions, and you're welcome to unmute and ask Lindsay directly. But this is also a good time to get your calculator out because we're going to do some calculations. It sounds like everyone's good. Let me look at the chat. If you know how you have several small leaks, do you see it?
Yes, how bad it is to be turning on and off. So if you're talking about turning off the main line as far as opening and closing the backflow, I would be hesitant to consistently do that because, because of water hammer or other things like that, you don't want to keep, you don't want to manage, you want to try to find that leak. But I do suggest, keeping that backflow closed as much as you can while you're investigating and try to figure out what's going on to keep your consumption down. But I definitely would not make that a habit.
What analytics software is the AMI data being displayed from?
It's from Census Analytics.
Okay. Okay, so let's see. Is that it? Okay, that's it.
I think Linda had her hand up.
Oh, Linda? Go ahead, Linda.
Oh, is that what you were?
Oh, you answered it. You answered
Okay.
it.
All right, super.
Yeah,
Great.
Analytics. Thank you.
Yeah, no problem.
Okay, we're moving on. Everyone
I think we got one more.
Oh. Where?
Yeah, quick question.
Yeah.
In terms of the software, is that a EBMUD piece of software that's available to accounts and professionals? You need to log in, say you're working on a site.
Yeah, so if your site has AMI in our service area, we can set you up to get the access to that. Usually it's the account owner that is able to get that access and set it up. But we have situations where we have set up like a generic email and login for customers so they can share that between a few different staff members because something about AMI that's really critical is making sure all that data gets to the people that are actually going to use it out in the field. So you can get set up and we can help you out with that, Mark. Just my contact information will be shared at the end of this and I can help you get access. Yeah.
Sounds good. Thanks.
Okay, I think we got the questions and everyone's got their calculator. So here we go.
All right, well, before we get into the calculator and the fun math work, let's chat a little bit and drill down into irrigation zone flow, right? We talked about system-wide zone flow and all of that. So we want to get into designed or expected flow rates, right? So we can understand and compare our expected flow or design flow to our actual flow. So flow rates are going to differ depending on what type of device you have, the pressure in your system, and the type of emitter that you are using. What we see here on this page is just a few examples of 3 different types of standard irrigation, components, sorry. Teams is sending me things. So over here on the left, we got an example of a standard nozzle. I'm sure many of you guys have these on your trucks right now. What this chart gives us is not the nozzle size, which you'll see over on the left. It shows 8F, which is a full nozzle, 8H half, 8Q, which is a quarter. Again, this is the size and the arc of the spray pattern. You also see pressure, your radius, which is also called throw. That's the distance that water's traveling from that device. And then what we're really after today, it's the flow, which is in gallons per minute here. The charts also give you precipitation rates, but we'll save that for another LAC meeting. Over on the right here, we have an example of a high efficiency nozzle chart. Again, very similar data. You got your arc pattern, your pressure, your radius, your flow, and your gallons per minute. These nozzles also will give you gallons per hour because it is a slower emitting device. Lastly, down here on the bottom, we've got an example of inline drip. So this is inline, which means the emitters are built into the tubing itself. And this again is giving us our flow rate, but you'll notice that this one is in gallons per hour because again, our drip is low and slow as I like to call it. So it's taking its time to get out of that device. So it's measured in gallons per hour.
Great. And Lindsay, we have a question. Heather has a hand raised. Heather?
Heather?
You can unmute yourself if you can. Oh, maybe she stepped away. We'll come back to Heather.
Yeah, save your question. We'll be happy to answer it at any point. And then this slide here is just to get you a little bit more of an up-close view of it. And I do want to remind you and discuss again that this is for an individual emitter device, right? So this is just the flow rate on one nozzle. To really, what we want to get after is the flow for an entire zone. So we need to calculate how many of these devices we have in each zone. So let's put all of this into practice. On this next chart here, a few things. One, I'm old school and still use Microsoft Paint. 2, we have a couple different zones on here. And what you're going to see is zone 1, you got rotors, which are marked with these blue diamonds. We've got spray zones, which are these light blue pentagons. And then that brown shaded area is going to be our drip zone for this example. And so just chime in here. Why do you think there's different numbers next to each of these devices? So example, in that spray zone, we have 3 different numbers here. What does that mean? Who knows? Who can chime in and tell me why we'd have different numbers?
Different patterns. So a quarter head is 1 gallon per minute, a half head is 2, and then a full circle, which is not there, would be 4.
Yeah, so that's correct. So it's different nozzles. Absolutely. You guys are all correct. So different nozzles going to put out a different flow rate, just like we learned from those charts on the previous slides. So when we want to calculate the total zone, we need to add up all of these devices. So this is pencil and paper and calculator time. What is our total design flow rate then for zone 1 rotors? Pop it in the chat or shout it out if you'd like to.
It's easier if you shout it out for us. If anyone's not feeling,
Eight.
Yep.
that's right. How about zone 2?
We'll give you a little bit more time on that one because the adding up is not as cut and dry as the previous one. So what's our sprays designed flow rate?
I got 13.8. I might be wrong.
No, you are correct. 13.8. That's right. Very good. All right. And so on this last one, this one's a little bit trickier. It's a little different, right? So I'm giving you a little bit more details here. We have a 500 square foot drip zone, 0.42 gallon per hour emitters spaced 18 inches by 18, emitter space 18 inches with 18-inch rows. So you could figure out the total emitter account by doing some additional math. But most manufacturers have really nifty drip calculators that you enter that data and then they will pop out the emitter count for you. So we're going to give you the emitter count here. We have 222. What is the designed flow rate for this zone?
93 gallons per hour.
What was that? Marco, you said 93?
Yeah.
Okay, anybody else? And what is that? 93?
1.5 gallons per minute.
That's right. Very good. So very good, everybody. Nobody seemed to get snagged up and understood that we were measuring, or these are in gallons per hour, and we needed to convert that to minutes. So 1.55 gallons per minute. Or a lot of you probably got that 93.24 gallons per hour. And so we took that, divided it by 60 to get our gallons per minute. So excellent job, everybody. So now let's take this information and compare it to actual flow. So we have our design flow. Let's take some meter readings and find out what our actual flow is. So here on this chart here, and then as a reminder, the flow rate formula is here as well. We're going to use that to calculate for each zone. So we have zone 1, we have a start and stop reading. We already did this math for you guys and got our consumption, which was 1.7 cubic feet. And then we ran the zone for 90 seconds. What is our flow rate for the zone? We'll give you a little bit more time on this one because you got to do a little bit of extra math.
Should they do all of them and then we'll check in? Or just one?
Let's just do one at a
Okay.
time. Yeah, because I have the animation set up like that, so it'll be fine.
Okay. Yeah, if you get it, you can put it in the chat or just call it out.
That was the last exercise.
Oh, okay.
Anybody got anything yet, or?
You see that?
I have 8.477333 gallons per minute.
Great. Yeah, so Paul is correct. So that, and we're going to go ahead and round it up, but yeah, that is correct. So again, we got that by taking our consumption, our cubic feet, that 1.7, multiplied it by our gallons conversion factor, which was at 7.48, multiplied that by 60, and then divided by the time, which was at 90 seconds. And that gave us our 8.477, which we rounded up to 8.5. All right, so let's give it a shot on the second one. Again, we have our start and stop. The consumption is 5.6 cubic feet, and the zone again ran for 90 seconds.
About 28 gallons.
Oops.
Yep. All right. So yeah, you should have gotten about 27.93, around that. So 27.9. So excellent job. All right. So on this last one, this one's a little different. Like this is our drip zone. So like I told you guys, it is very low and slow. So we needed to run this for a little bit longer than normal to actually get register consumption on the meter. So this one, we have 1.5 cubic feet, but we ran this zone for 10 minutes, which is 600 seconds. What do we get for the gallons per minute on this one?
1.12.
That is correct. Paul, you're knocking out of the park today. Great. That is excellent. So let's pause real quick. I want to make sure everybody understood how we got to these numbers. And if you have questions about the formula or how we got to there, please raise your hand or chime in or ask now before we actually compare these to our design flow. Okay, all right, excellent.
So we're basically just, checking how much water was used in a certain amount of time, figuring out how many gallons went out per a certain amount of time. That gives us gallons per minute.
Yep, that's correct.
Yeah, okay.
Yeah.
So you do that in the field because then you're going to compare it to how it was designed and
Yeah.
then from there assess, is there anything wrong?
Yeah, so let's do that. Let's compare it. We got all of our design flow rates on our previous exercise. We just got our actual flow rates on this one. So let's pop these in a chart. So zone 1, our design flow was 8, right? Our actual flow rate was 8.5. Go ahead and pop all of them in.
Okay.
Yeah. Great. Zone 2, our design was 3.8, actual was 27.9. Zone 3, 1.55, actual 1.12. So what do you guys observe about this? Let's start with zone 1. How does that look to everybody?
What would you say?
Pretty close.
Yeah, it's pretty close, right? No irrigation system is going to be 100% efficient. We all know that. So this one's good. We would say this is within that range we're comfortable with. Yeah. Does somebody have a question? No? Okay. All right. So the second one, what do we think is going on here?
Broken head?
Lateral.
And laterals, yep.
Lateral, probably.
Yep, we have a leak. Something's going on here because we have double what we expected out of this zone. And then this last one, this one could be a little bit tricky, but what do we think is going on with this zone?
Valve issue?
Perhaps, yeah, we got low flow, right? So it could be a valve. It could be low pressure on the system. It could be clogged emitters. So it could be a few different things. Great. Excellent job. So what causes all these problems?
Lack of maintenance.
Yep, lack of maintenance, and some of these guys here. Mainline lateral line breaks.
Yeah.
Which you can see in this picture over here in the upper right-hand corner. I love this picture for a few reasons. One, I only ran that zone for probably 30 seconds. You can see tons of water going to that storm drain. But if you look up to the left too, you can see that there's actually an additional lateral line also contributing to this water loss. But if you look at the pavement, you can kind of see around where the leak is some staining and discoloring. So that's going to indicate that this has probably been going on for some time and just hasn't been addressed. Stuck weeping valves are also a huge problem. We've all dealt with these before. There's a picture in the lower left-hand corner of a drip valve that was left on or stuck on over a weekend. This could happen from the valve not closing properly, or this could have been, somebody turned or opened that valve manually and forgot about it. I know some of you guys in landscape maintenance have probably dealt with this a lot more than you would have liked to have. Most common, broken sprinklers or nozzles. We see these all the time, but they're a huge water waster. And then not pictured here, sometimes you might have a leaking quick coupler or a hose bib that hasn't been turned off all the way. This was something I didn't really check for before in the past. And, I was racking my brain trying to figure out this leak, spent hours, went through all these valve boxes, checked all these different things, couldn't find this leak. Well, I didn't check any of the quick couplers. So I went back through again and retraced my steps and went and opened all my quick coupler boxes too. Lo and behold, I found a slow weeping or leaking quick coupler valve. That was the root of my problem. And then lastly, improper programming on a controller, or you've forgotten about battery controller. Battery controllers are great because they allow us to automate a valve that we normally wouldn't be able to automate. So they're really wonderful for that aspect. But these things are sometimes out of sight and out of mind. So they get forgotten about and maybe don't get turned off for the winter or don't get adjusted seasonally. So AMI and irrigation. So we talked a little bit about AMI and the data it can provide us. Why is this useful for irrigation? Well, like I mentioned earlier, it helps us to compare our actual usage and what's happening versus irrigation schedules. So you can check your irrigation schedules. If you see that water's not supposed to be running and it is, you know you have a problem. Like I mentioned, it can detect new leaks or spikes in usage, identify that continuous usage, which you can see in this AMI chart here on the left. Not only is this showing us that continuous usage in orange, but you can see at the end of January where that usage really dropped off. So to me, this indicates that they probably turned that irrigation controller off. But again, just turning off the controller doesn't necessarily stop your water from getting wasted if you have a broken main line or a stuck valve going on. So they most likely shut the clock off, which we should do, but that leak was still going. So if you look from January going into March 2024, you have that continuous usage. And then you also, this is the alert that got sent out with this account or for this account. It gives us the time that it noticed this. It gives us the estimated gallons we're losing, the duration. And what's really great is it gives us an estimated water loss rate, which here is 448 gallons per hour or 7.5 gallons per minute. So it can help you quantify and understand what kind of size leak you might be dealing with. And then here's a customer.
Want to see, let's see if there's any questions here.
Oh, okay.
Yeah, are there any issues with leak detection and add-a-zone mechanism?
Oh, so I haven't really ran into too many issues with add-a-zones for when I was doing leak detection out in the field. You know, the add-a-zones are great because they give you that ability to get that valve onto, you know, if you don't have the wire to get it to the controller, it does give you that ability. But I haven't really run into too many problems with that in the field. I don't know if anybody else has and wants to chime in on that. Feel free, but I have not run into too many difficulties with it.
Oh, she needed me.
Yeah. Do we have any other questions? Or go into the customers? No?
Yeah, you can.
Okay, great. So this here is an example of a customer that we've been working with. They have an AMI meter, and they started receiving alerts for a leak that was about 74 gallons per hour or 1776 gallons per day. That leak grew to almost 900 gallons per hour and over 20,000 gallons per day with intermittent large spikes. So we started working with them to help figure out what was going on. Very complex system, over 35 controllers, 3 different types of central control units, which allows you to manage your clocks and can manage points of connection all in one online platform. As we were investigating, we saw some patterns in the usage that didn't quite make sense because when we looked at the CCUs, there really wasn't anything on there that indicated that anything was running. So the customer's contractor then went through and physically checked all of the irrigation controllers and then found that one had not been communicating to the CCUs, but was actually programmed to run and operate. So we refer to this sometimes as a ghost programming or ghost programming. And this was just the controller was not communicating with the cloud. So that data wasn't getting uploaded. So we got that resolved. The customer got that resolved. We saw the usage go down. During this process, the customer also identified and repaired a bunch of different leaks because as you can see in these photos below, they have some of the best site maps I've ever worked with or seen. This map is really useful and incredible because it shows you all of your irrigation valves. It shows all the gate valves, the main line path, where quick couplers are located. And this is really great because it gives you the ability to isolate sections of your main line and isolate sections of the valves as well, which can help make a big site like this a little bit easier to manage as far as leak detection. All right, so what if you don't have AMI? I wish everybody had AMI. It is incredible. I love working with it, but it might not be available. So there's some other really great, fantastic devices you can use if you don't have it. One being a flow meter. These can get installed directly on a meter. Some can get installed inline. It will usually communicate through some sort of app. Some can be connected to irrigation controllers. The next would be a sub-meter. You could sub-meter your irrigation. This is useful if you have a mixed use meter and you want to be able to track your irrigation separately from your other usage. You can install a sub-meter at the point of connection for your irrigation system and either just manually read it or some will communicate electronically. And then one of my favorite devices and one that I use and recommend a lot are flow sensors. Flow sensors are fantastic. So this device is installed on your irrigation main line. It's connected and communicates with your controller. And not only is it going to let you monitor the flow of your whole system, but it's going to give you the ability to monitor individual zones. So, we did all this math earlier in this presentation, and we talked about going out and counting heads, learning the flow rate of our nozzles, calculating all of that together so we could get our expected flow from our zone. This device could do all of that for you. But I do want to stress it's really important that it's set up properly, because if it's not programmed and set up properly, it's not really going to be useful for you. But when it is, I think it's the bee's knees. It really they are just wonderful devices. And some of them even have the ability to shut down watering. If you pair it with a master valve, which I also highly recommend, it can actually completely shut down all watering on your system. So your leaks won't continue to leak and they'll get stopped. You'll get an alert and you can get it addressed quickly. All right, so what are some of the tools we use for leak detection? So wire tracing or valve locators are useful tools. You would especially want to use this if you aren't one of the lucky ones who has site maps or as-built showing you where your mainline path is. You can clip this onto your common wire or onto a field wire, and you can trace that wire path, which irrigation wire is installed with the irrigation main line, and it'll let you, it'll give you the ability to map out where your main line is. Another device we use is an acoustic listening devices. Over here to the right, you can see our colleague Alan listening to an irrigation valve. And the picture to the right of him just kind of shows an up close of what that equipment looks like. And then you can use a piece of PVC pipe. This is the poor man's acoustic device. I actually used to use this in the field quite a bit. If you cut a piece of PVC pipe, I usually used 1.5 or 2 inch, and you can put it down on your valve or on your pipe and put your ear up to it, and it'll actually amplify that sound. So it can be helpful for listening.
Quick question.
Sure.
Are people using these acoustic things? I mean, it sounds like you've used it, and is it worth buying that hardware there, electric, or all that, the blue stuff you had in the previous slide?
Oh yeah, the acoustic device, yeah. So I will say here at EBMUD, I've used those more as a contractor. I did not really use them too much. I did use wire tracing equipment. And I did use a piece of PVC pipe. So it's really up to you. Me personally, I don't really think you need to get one, but if it is helpful, especially if you are working somewhere where it's really noisy and you might not be able to hear water movement a lot. If you're working for Caltrans or you're working by highways, or it's just really a loud environment, it could be. It's definitely useful. So I hope that answers your question. It just really is your personal preference.
We're going to be demonstrating wire tracing at our June 6th in-person event. Lindsay's going to be doing that if anyone's interested.
Yeah.
A mechanic stethoscope is really handy. If you
Just as a quick comment, for like $18, go buy a reasonably good set of stethoscope from CVS.
Mechanic.
Well, there's the mechanics that has a rod. You can do that. I prefer the actual stethoscope because I can place that down along the side of a valve, and you're essentially doing the same thing, but without batteries and amplifier. And it's inexpensive.
Sounds
Yeah.
like Paul.
No, that's a good recommendation. And yeah, that's the listening device, the acoustic listening is essentially a really fancy, high powered stethoscope. So
Yeah.
yeah, that's really great. Yeah, that's a great tip.
And going back 2 slides, the flow sensor, flow meter, something that I've had to wrestle with is that these things have certain ranges that work, like the flow sensors. If they're like 1.5 inches and larger, they're not going to really record very well anything under 1 or 2 gallons a minute. And it's a dilemma sometimes. You have a flow sensor, but you can't measure the small stuff. I don't know.
Yeah, yep,
It's
absolutely. Yeah,
Actually,
so sometimes.
actually, there are flow sensors that don't use paddle wheels. They use I
Ultrasonic.
want to say an ionic charge across it, and they can detect flows down to like, I want to say like 1/4 gallon per minute.
Yeah, yeah, there's definitely some new products and there's some hydrometers too on the market that can get those low flows. So yeah, and you can also downsize the flow sensor, which is what will happen sometimes. You'll have like a 2-inch main line and sometimes you'll downsize to like, or let's say you have a 1-inch main line, you can downsize to a 3/4 inch flow to kind of help pick up that. But yeah, that is definitely, and like I said, the flow sensor thing, when you have them fine tuned and you have the appropriate flow sensor for the capacity of your system, they work really great. But it is, you have to put the effort into getting them set up properly and making sure that you size it right.
Great, thanks for the input.
Okay, all right, back to some of our tools. So a chlorine testing kit. I don't know if some of you worked with these or not, but you take a sample of water, you spray a little bit of that powder in there. If it turns pink, you got chlorine. This is useful if you see puddling on your job sites and you're not quite sure if that's potable water or if it's groundwater. This will help you determine that. And then lastly, if you get as-built, you're one of the lucky ones. These magically disappear all the time. We don't know what happens to them, but if you get them, hold on to them because they're incredibly useful and valuable, especially for leak detection. It's going to give you all the details you need to know. And again, sometimes the as-built aren't always correct, but it's going to give you a lot more information and more of a starting point than having absolutely nothing.
So we want to hear a little bit from you. Lindsay's going to go through her steps of what she does to detect leaks. And but want to hear a little bit from you, and you can put it in the chat or feel free to unmute. What steps do you take to find irrigation leaks?
Listen to the backflow.
Mhm.
Listen to each device. Visually check.
Yeah.
If you turn off the backflow for a matter of like 30 seconds or maybe a couple of minutes, and you turn it back on and you hear flow, at least that recharges the line, then that tells you you've got something downstream. The longer that it's off, obviously it'll do that. But if it takes a long time to recharge that line, that tells you got a lot more flow going through there. That's a trick from a guy who's been doing backflow testing for about 20 years.
Nice. That's a good tip.
Does anyone use AMI data or flow sensor data?
Absolutely.
Has that helped to find the leaks?
It helps detect them, especially when it's been a long weekend and suddenly on Tuesday morning or Monday morning you get the email. Step one is to get subscribed properly. Lots of customers get them, but they don't know what to do with them.
Exactly. Yep. Yeah, that's where we're here to help. When we get sometimes your customers, they think you guys are trying to sell them something. We're not, and we're happy to help you explain, share that data with your customers. Because at the end of the day, we all have the same goal here: is we want to do the right thing, we want to save water, and we want to help our customers. So great. Does anybody else have any tips or things that they use when they're out looking for leaks? I appreciate everybody chiming in on this.
We also use, because of the larger sites have a lot of isolation valves.
Yes.
When they build out a site, a lot of times we'll turn off, branches and see if that eliminates the issue. And that at least allows us to go one particular quadrant on the property. And then if we have to call out a professional service to charge the line and listen for it, at least we can narrow it down. They charge, they charge a lot of money if they're doing it. So if you can isolate a region and then just start flipping boxes and listening to the quick couplers in those areas and the individual station valves, that may help.
Yeah, no, those are great, and those are some items that I'll be reviewing
For
in my steps
residential,
as well.
if you have a leak and you can't seem to find it, and you have it stationary, you have a back slope going into an undeveloped area, look for water going out the back of the property and possibly even to a drainage pipe.
Absolutely. No, these are great tips. John, I see you when you're looking for lateral, you use pressure. Okay. That's really great because you will see those pressure fluctuations. So these are fantastic tips and tools. Great. So let's go into some steps. And I do want to take a second, why I know these things. I want to shout out to Eric Santos. I think you're on the call here. My time spent with him in the field out in Brightview and Valley Crest days, really just like why I was able to get to these points here. So I just want to give a shout out, give credit where credit is due. So what do we want to know? First, we want to know what kind of leak we're dealing with. So we're going to take, if we don't have an AMI meter, right, we want to quantify and get that flow rate on our leak so we understand what we're dealing with. Then we want to rule out other usage. So, are there bathrooms? Is there a pool? Most of the audits I go on, the first thing I look at is if they have a pool or not, and I go and I check that autofill valve. If you're not able to isolate those, if there's a bathroom on the line or something like that, and you're not able to isolate it when you're leak detecting, go in and audit the fixtures inside of the bathrooms to kind of help eliminate that as a potential area. And then, like Marco said, and like Paul and other people were mentioning, watch your site. Go out, start at that backflow, know where that backflow is, know where controllers are. Go start looking for valves. Look for wet areas. If you see a bunch of nut sedge growing in your planting bed, you have water over there. There's probably a leak nearby. Use those chlorine tests if you come across some wet spots and you want to know if it's water from a potable system or is it groundwater. And then locate those valve boxes because that next step is we want to start looking at those irrigation valves. So this step here works really well if you have two people, which I know some of you're just sending one tech out in the field. It can be a challenge. But if you can have one person at the meter checking, one person at the valves, have them close those flow controls down, see if that makes an impact on the meter. And then when you're messing around with those valve boxes, check for any of those battery operated valves. And don't forget to check those quick couplers. Because like I mentioned earlier, that was a hard lesson that I learned. All right, and then let's trace that main line. We want to know where that main line path is, because if we have a main line leak, we'll be able to identify it a little bit easier if we actually know where the main line's running. And again, look for those weedy areas or really green patches. If you don't know where the main line is, like I mentioned earlier, pop a wire tracer on the common, and it'll help you identify that main line path. And then isolate that main line wherever possible. Paul touched on this a little while ago when we were talking about what you all do in the field. If you have a series of isolation valves on your main line, you're in really good shape. So let's say we have a leak on our main somewhere. We start at the meter. We go to that first isolation valve. We shut that valve. The leak stops. We know that leak then is further down the line. So we got to keep working. So we open that first valve up, go to the second isolation valve. We close that one. The leak stops. So we know we still have to keep going down that line. So we go to the third isolation valve on the path. We open the second one back up, and then we close that third one. The leak is still happening. So now we have found that leak between that second isolation valve and that third isolation valve, which again, helps us narrow down where our leak is. And if you do have to utilize leak detection services, you have at least narrowed that path down. We'll talk a little bit more about that on step 8. And then use those acoustic devices. A bunch of you have mentioned use stethoscopes, really great tips. So listen for that water flow. And then worst case scenario, and what we all try to avoid, except for leak detection companies, is consulting leak detection services. These services are usually pretty expensive. So you want to try to eliminate everything for the customer, try everything first before you go that route. If you're able to, like what we talked about earlier, isolate that leak further on your main line, it's going to be a lot cheaper for you and for the customer. The leak detection services are either going to pump air through and listen, kind of what we're already talking about doing. If it's bad enough, or if it warrants it, it's noisy, things like that, they might pump helium through the line, and then that's going to start really getting expensive. So we want to take all these other steps before we go to step 8. All right, so here's an example where we use kind of these steps in this process to help one of our customers out in the field. They had actually reached out to us. They had a bioswale flooding issue that they thought was related to, an East EBMUD service line. So we went out to help troubleshoot and look around. It was actually a groundwater thing, because we did do a chlorine test. There was no chlorine in the water. We did check the irrigation in the area. Nothing was going on. But while we were out there, we also went through the whole system, because this was a customer that had also been over their water budgets. So we wanted to help figure out what's going on. During our walk, we found the lead gardener, and this is something that is incredibly valuable because this guy had a binder full of as-built, which was awesome. It was just really great. He knew where everything was, and was able to kind of work with us and start shutting off isolation valves, which you can see on this map on the lower left-hand corner here. The main line is kind of hard to see, but I circled with red dots 2 isolation valves that we had closed, and we were able to narrow down the main line leak between those 2 valves. This area was a really giant, large, huge park. So to be able to narrow it down to that small of an area was really helpful. And then they were able to find and fix actually 2 different mainline breaks in that little stretch. On the right here is another example of an area where we suspected there might be a mainline leak under pavement, which nobody wants that to have to happen, because when you're tearing up asphalt and you got to get an asphalt patch done, it is a lot of work and it's really expensive. So what we did is we actually found isolation valves on each side of the pavement, so we could isolate that little section. Well, it turns out the leak wasn't actually under there, thank God. It was a little bit further down the main line, but we were able to eliminate that as the possible root of the leak, which did make it a little more palatable for the customer. And then, having these plans really just, this would have taken us a really long time, and it would have been difficult to figure out had we not found that guy with these landscape plans. So if you get your hands on them, keep them somewhere safe. I know some of us might hoard them or not want to give them to another contractor, but it's just a really valuable tool to have. And with that, I pass it back over to Kristen.
Oh, let's see. Okay, so, well, thank you so much for all your participation. And I know it sounds like all of you have some experience with, these irrigation leaks and using your own techniques. I'm hoping that you also were able to glean some new insight. And just in summary, to calculate the irrigation zone flow rate and compare it to the design and expected zone flow rate is, you can do this to determine if there's a leak or a blockage. Use the AMI hourly data or daily, monthly, and yearly data to evaluate water consumption and see, and you do want to use those leak alerts to check, to catch leaks early. Use the site maps, use the survey the property and the acoustic devices and wire tracing, chlorine tests for check for leaks. Also come join us June 6th for our irrigation leak detection in person. And you'll be getting a link to that invitation in the email today. And then take advantage of all of our rebates, including our new spring irrigation repair. And this is all about really having a water conservation culture, whether there's a drought or no drought. All these small changes that we can do to catch these leaks leads to a big splash. So what we'd love to do right now is to just do a quick trivia, and then we will end with questions. And Jolene, are you able to launch the
Yes, trivia is up.
trivia?
Everybody should be able to see 5 questions on the screen. We'll give everybody about 30 seconds to breeze through those.
Oh, because you're the host and I'm a participant, so I can answer and I better get them right.
Okay.
Yeah, so that first question, which irrigation issues can lead to water loss? And then, yeah, there's 5 of them. So hopefully everybody can see that on the screen.
Can you do a whole? Go ahead. You can do it.
Oh, no, this is just showing me the poll because I'm a co-host.
Oh,
Yeah.
okay.
Yeah, I want to leave it open to allow people to answer,
Yeah.
and then I'll end the poll and I'll be able to share the results.
Okay.
Is it just one question?
There's 5 questions. You should be able to scroll down.
Oh, no,
Does it not show up on your screen?
no, I just had the first one and I answered it and it went away.
Oh.
I see trivia and dopamine displayed. That page.
You only get a little dopamine, Marco.
Yeah.
Yeah, only one drop.
Is everyone seeing all 5 questions?
I saw all 5.
Okay.
User error.
Okay.
Yeah, I'm on question 4.
Okay.
Great.
And what are the prizes, Kristen?
I already told you what the prize is.
Dopamine.
Feeling good.
Feeling good about ourselves.
Confidence in your knowledge.
That's right.
Even if you just participate, you don't have to get the answers right. You still get dopamine.
All right, we'll just give it about 10 more seconds.
I like the seashell idea.
All right, should we see how everyone did?
Yeah, let's see.
Yeah, let's see.
Do we get any seashells?
Okay, can you see the results up on your screen?
I see the results.
Now I see it. Yep. Scrolling.
Why don't you just call it out, Julene, for the right answer? You know the right answer, or we can. So which irrigation issue can lead to water loss? What's the right answer on that?
Above.
All of the above.
the
That's
above.
right.
All right.
Very
And
good.
then if you do not have automatic metering infrastructure, AMI, to see hourly water use data and set leak alerts, what other type of irrigation equipment can be used? What's the right answer on that?
Flow meters or flow sensors.
Flow meter or flow sensors can be used. Why do you calculate actual versus designed irrigation flow rate? Because I love doing math, or to determine if there is a leak or blockage in the system.
Or
The second one is the correct
Yeah,
answer.
so we want to determine if there's a leak. The convert to cubic feet to gallons was thrown in there to be a little tricky. So I figured, a few of us might guess that one.
Yeah. If you do not have an acoustic listening device to listen for leaks, what can you use instead? We got someone. PVC pipe, but you could also use a stethoscope, as
Very
Paul
good.
said. And when you find and stop a leak, you save water, money, and contribute to water conservation. Small changes leads to a big splash.
And
Here it is,
potentially a
right.
loud roar.
Yeah, a
Yeah.
roar of excitement because
Yeah.
we're saving water.
So we have a few more minutes for questions, if anyone has any more questions.
Is there gonna be any CEUs available for this? This was a really good presentation, by the way.
Oh, for
thanks.
sure. You can, most of them are self reporting, right? So I don't actually have a CEU number, but typically you just say you attended this event on this day and you get the CEU. Even Irrigation Association will accept them.
So do you folks happen to lease out or rent or any equipment like these high-end listening devices? So if we wanted to test it out and get some practice with it before purchasing it, is there any leads on those?
That's a really great question, and that would be something I have to talk to the Soups about, but I kind of like that idea. But we you know, for the infield portion, we are going to be doing some wire tracing so you can get your hands on some equipment to test it out. But I actually really like that idea. We do have acoustic listening devices here that we use when we're doing site audits, same for wire tracing equipment. But, you know, Paul, that's a really great suggestion and something I will bring up to our supervisors about potentially doing something where we could do some more stuff in the field to give you all an opportunity to test out some of these devices for sure. Because it's an investment, you know, the equipment's not cheap. So you want to know what you're getting, right? And you want to get your hands on it and use it a little bit before you make that purchase.
Where is that June event gonna be, June 6th?
It's in Walnut Creek. It's gonna be and so you sign up and then you get the and then you get the details.
You know what time it is? Can
It's
you-
from 10 to 12:15-ish, and we'll have 3 stations set up and depending on, and just rotate between those 3 stations. One of them will be wire tracing, one will be like auditing a zone, and then one will be getting the flow rate from a meter. And then you get to ask all these questions in the field. It's one thing to do it like on paper, right, in a table, but another thing to do it in the field.
Great.
And so it is we do have a limit of how many people we can attend, so I'll be sending that out, and if you do really feel like you want to go, I would just go ahead and sign up.
Great.
Any other stories, or we're just about at time? Wow, right on time. But anything else people would like to share? Any successes, leak?
Any crazy leak stories out there, or just wild irrigation things you've dealt with?
I heard a story of some municipal system in Santa Cruz that had a mainline break that was going straight into a storm sewer, so they just couldn't see anything above ground, and it ran for took a really hard time finding it.
Oh, wow.
Yeah, it's difficult. Leak detection is tricky and challenging. And you know, sometimes you might not find it. And you're just wreck your brain and it'll drive you crazy. And it can be a lot of work. But when you do find it, you can have that loud roar.
It was
Or a big splash.
Well, you don't want the big splash with a leak.
That's true.
Hey,
Okay.
thanks very much. This is very
You're
informative.
welcome. Thank you so much for joining us today, and we'll see you again soon and out in the field.
Thank you.
Everyone,
Okay.
thank you. Bye.
Bye-bye. Bye.